The termination temperature for the T-lead connections of a 30 horsepower, 460 volt, 3-phase motor is 90 degrees Celsius. The standard termination temperature for low voltage motors, those that are below 1000 volts, is 90 degrees Celsius according to the National Electrical Code, specifically Table 310.15. B16. This table provides ampacity ratings for conductors insulated at various temperatures. The 90 degrees Celsius rating signifies the maximum temperature that motor connections and terminals can withstand without risking insulation damage or leading to premature failure. Motor starters, responsible for safely energizing and de-energizing motors, are generally rated for a lower maximum ambient temperature, frequently 75 degrees Celsius. This lower rating considers the additional heat produced by the starter's internal components during operation. Nevertheless, the motor connections themselves must still be capable of withstanding the higher termination temperature mandated by the motor manufacturer's specifications. Therefore, when selecting the appropriate wire size for the T-lead connections of a 30 horsepower 460 volt 3-phase motor, it is crucial to simultaneously consider both the termination temperature of 90 degrees Celsius and the ambient temperature rating of the motor starter, typically 75 degrees Celsius. Selecting the correct wire size based on these temperature considerations is vital for ensuring safe and reliable motor operation. If the wire is not properly sized, several potential problems could occur. Firstly, undersized wires can overheat. The increased resistance due to the smaller cross-sectional area causes the wire to generate more heat as current flows through it. This excessive heat can degrade the wire insulation, leading to short circuits and potential fire hazards. Secondly, voltage drop can become significant with undersized wires. The voltage at the motor terminals may be lower than required for proper operation, causing reduced motor performance, overheating, and potentially premature failure. Thirdly, using wires rated for lower temperatures than the termination temperature can also lead to insulation breakdown and failure. Over time, the heat from the connections can degrade the insulation, making it brittle and prone to cracking. This can create a safety hazard and lead to equipment downtime. The National Electrical Code specifies requirements for conductor ampacity based on the termination temperature rating of the connected equipment. It is imperative to consult the relevant NEC tables and sections to determine the minimum allowable wire size for a given motor and starter combination. Remember that the wire must be rated for at least the higher of the termination temperature or the ambient temperature. To properly size the conductors, consider the following steps. Firstly, determine the motor's full load amperage FLA from the motor nameplate. This is the amount of current the motor will draw under normal operating conditions. Secondly, apply any applicable correction or diluting factors. Correction factors may be necessary if the ambient temperature is higher than the temperature rating of the conductor. Diluting factors may be required if multiple conductors are bundled together in a conduit or raceway. Thirdly, select a conductor size from the NEC tables that is rated for at least 125% of the motor's FLA after applying any correction or diluting factors. This accounts for the motor's starting current, which can be significantly higher than its FLA. Fourthly, verify that the selected conductor is suitable for the termination temperature of the motor and the ambient temperature of the motor starter. The conductor's insulation temperature rating must be at least as high as the higher of these two temperatures. In practical terms, this means consulting NEC Table 310.15. B16 or similar tables to find the allowable ampacity of different wire sizes at different insulation temperatures. Be sure to choose a wire size and insulation type that is rated for at least 90 degrees Celsius at its termination points. The standard size of motor starters typically includes a 75 degrees Celsius rating to compensate for the additional heat produced by the starter components. However, the wire to the motor still needs to be rated for the temperature at the motor terminals. It's also important to understand the different types of insulation available for conductors. Common insulation types include THHN, THWN, THW, and XHHW. Each insulation type has a different temperature rating and is suitable for different applications. For example, THHN and THWN are commonly used for general-purpose wiring in dry and wet locations, respectively. XHHW is a high-temperature insulation type that is often used for motor feeders. To summarize the process, firstly, identify the motor's full load amperage. Secondly, apply any applicable correction or directing factors as per the NEC requirements. Thirdly, determine the minimum conductor ampacity by multiplying the corrected full load amperage by 1.25. Fourthly, select a conductor size from NEC Table 310.15. B16 that has an allowable ampacity greater than or equal to the calculated minimum ampacity and is rated for at least 90 degrees Celsius at its termination. Keep in mind that using larger conductors than required by the NEC is generally permissible as long as the conductors fit within the equipment terminals and raceways. In addition to wire size and insulation type, it is also important to select the correct type of conductor material. Copper and aluminum are the two most common conductor materials. Copper has a higher conductivity than aluminum, meaning that it can carry more current for a given wire size. However, aluminum is less expensive and lighter than copper. When using aluminum conductors, it is important to use connectors that are specifically rated for use with aluminum. Aluminum conductors can corrode when exposed to air, which can lead to increased resistance and overheating. Proper termination techniques are also crucial for ensuring safe and reliable motor connections. The terminal should be clean and free of corrosion. The wires should be properly stripped and inserted into the terminals, and the terminal should be tightened to the proper torque. It is also important to use the correct type of lug or connector for the wire size and type. Proper torque is essential for making a good electrical connection. Over-tightening the terminals can damage the wires or the equipment, while under-tightening the terminals can lead to loose connections and overheating. Torque specifications are typically provided by the equipment manufacturer. When working with electrical equipment, it is always important to follow safe work practices. To energize the circuit before working on any equipment. Use insulated tools and wear appropriate personal protective equipment (PPE) such as gloves and safety glasses. If you are not comfortable working with electrical equipment, hire a qualified electrician. Failure to follow safe work practices can result in serious injury or death. It is also crucial to consult the motor manufacturer's specifications for any specific requirements or recommendations regarding wire size, termination temperature, and other electrical considerations. These specifications may supersede the general requirements outlined in the NEC. For example, some motors may require larger conductors or higher temperature ratings than what is specified in the NEC. The motor manufacturer's specifications should always be followed to ensure proper and safe motor operation. In addition to the NEC and the motor manufacturer's specifications, local codes and regulations may also apply. These codes and regulations may have additional requirements or restrictions regarding electrical installations. It is important to be familiar with all applicable codes and regulations before starting any electrical work. Failure to comply with these codes and regulations can result in fines, penalties, and delays in project completion. When in doubt, consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. To further illustrate the importance of considering termination temperature, consider a scenario where a 30 horsepower, 460 volt, three-phase motor is installed in a hot environment. The ambient temperature around the motor starter is consistently above 40 degrees Celsius. In this case, it may be necessary to use conductors with a higher temperature rating than 90 degrees Celsius to compensate for the high ambient temperature. The NEC provides correction factors for conductor ampacity based on ambient temperature. These correction factors must be applied to determine the adjusted ampacity of the conductors. If the adjusted ampacity is lower than the motor's FLA, it will be necessary to use larger conductors or conductors with a high temperature rating. Another factor to consider is the type of enclosure used for the motor starter. Enclosures are designed to protect the starter from environmental factors such as dust, moisture, and corrosion. However, enclosures can also trap heat, which can further increase the ambient temperature around the starter. When selecting an enclosure, it is important to consider the ventilation requirements of the starter. Some enclosures have built-in ventilation systems, while others require external ventilation. Proper ventilation can help to dissipate heat and keep the ambient temperature within acceptable limits. In summary, selecting the correct wire size for motor T-lead connections requires careful consideration of several factors, including the motor's FLA, the termination temperature, the ambient temperature, the conductor insulation type, the conductor material, and any applicable correction or directing factors. It is essential to consult the NEC, the motor manufacturer's specifications, and any applicable local codes and regulations to ensure that the installation meets all requirements. By following these guidelines, you can ensure safe and reliable motor operation and prevent potential problems such as overheating, voltage drop, and insulation failure. Remember, working with electrical equipment can be dangerous. Always follow safe work practices and consult with a qualified electrician if you are not comfortable performing the work yourself. Proper planning and attention to detail are essential for successful and safe motor installations. By taking the time to carefully consider all of the relevant factors, you can ensure that the motor operates reliably for many years to come. Therefore, the selection of wire size requires an understanding of various electrical parameters and regulatory standards to prevent unwanted events.